Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over section 3.6 of our virtual algebra text, focusing on how to solve absolute value inequalities. This standard is covered in Algebra 1, 2, and Pre-Calculus courses. Don't forget there are 4 practice problems we have at the end of this presentation. We'd like you to try them out so that you can demonstrate mastery of the contents that we covered in this presentation. We have a wide variety of resources that you can gain access to in our playlist, so just visit our website at mathgotserved.com. Alright, instructions for the examples that we're going to work on are as follows. We're to solve the given absolute value inequalities. So we're going to do two things, okay? We're going to solve them and then graph, okay? And graph the solution. All right, let's take a look at question number 1. So let's say we have the absolute value inequality given by the absolute value of x is less than or equal to 5. So let's do this. Now, one thing you want to remember is that if you're solving an absolute value inequality that involves less than, your solution is going to be a sandwiched solution or a bounded solution, okay? But when you have greater, it's going to be an unbounded solution. So we have absolute value of x less than or equal to 5. So because we have less than or equal to is going to be bounded. It's going to be a bounded solution, or think about it as a sandwich or a conjunction. So let's go ahead and solve this. So to get rid of the absolute value, we write this as plus or minus the absolute value, plus or minus x is less than or equal to 5. Okay? Now, since it's bounded, we can write this as a combined inequality. This can be written as negative 5 is less than or equal to x, and x is less than or equal to 5. That's what a bounded situation is. It means that x is between negative 5 and 5. You use this approach when you are solving absolute value inequalities that are less than or equal to. Okay? All right, so there goes the solution right there. Let's go ahead and graph it. So to give you a visual as to what a bounded inequality scenario looks like. All right, so we're just going to graph negative 5 is the lower bound, and the upper bound is 5. So we're going to go from negative 5 to 5. You're bounded in between. Now, are the endpoints included? Well, since you have a line underneath your inequality, that means that the boundaries are included. Okay, so you have the boundaries and within. And this, ladies and gentlemen, is the solution to question number 1. Alrighty? Okay, let's take a look at another example, number 2. Let's say we have the absolute value of x is greater than 1. Okay, so let's see how to solve this one. Now, if you look at this scenario, you're dealing with greater. Remember, we said less than implies bounded, right? When you have absolute value and greater than, the opposite of bounded is unbounded. You are on the outside. So you're not constrained by the boundaries of this inequality. Okay? All right, so to drop the absolute value bars, we'll represent it with plus or minus x is greater than 1. Okay, this is a disjunction. So in order to solve this, we have to split the inequality. So we have negative x is greater than 1, or for disjunction, x is negative or positive x is greater than 1. We split it along the sign, okay? The negative goes over here, and then the positive goes over there. All right, let's finish this off. You divide this one by negative 1. Now, what happens when you divide an inequality by negative? The signs flip, okay? So this becomes x is less than 1, or -1, sorry, because positive divided by negative is negative, or x is greater than 1. So you're either to the left or to the right of your boundary points. Let's give ourselves a visual as to what we're talking about here so you can see exactly what's going on. So you have -1 and 1. The boundaries are going to be open because there are no lines underneath our inequality. So everything to the right of the right endpoint and everything to the left of the left endpoint will satisfy this inequality that we have right here. Ladies and gentlemen, this is the answer to question number 2. All right, let's take a look at another example. What if we have the absolute value of x is greater than or equal to 10? Now take a look at this. Greater, is that bounded or unbounded? So remember, greater means you're outside the boundary region, which means that you are unbounded, okay? Just like number 2. But the difference between 3 and 2 is that for number 3, the boundary points are included in the solution region. Okay, so since it's greater, it's going to be unbounded also. Okay, so how do we get rid of the absolute value? We replace it with plus or minus. Plus or minus x is greater than or equal to 10. And then we're going to split it, okay? So we have the negative part. And then the positive part. The negative part, we need to get x by itself. So what do? We divide by -1. And that gives us x is what? When you divide by negative, so this slash and dash becomes positive. When you divide by negative, the inequality switches, so less than or equal to 10, or x is greater than or equal to 10. That's the solution in inequality format. Let's go ahead and graph it to give ourselves a visual as to what the solution looks like. This is an unbounded region, okay? So you have the boundary points are -10 and 10. The boundary points are included in the solution region. How do we know that? Because our inequality has a line underneath, okay? That line means that the boundary is included. So any point on the left boundary or to its left, or any point on the right boundary or to the right, will satisfy the inequality given in question number 3. Okay, let's take a look at one more example, then we'll give you some practice problems. Okay, let's take a look at question 4. So question 4, let's say we have the inequality, absolute value inequality given by the absolute value of x is less than 1. All right, so let's do this. Now take a look at this scenario that we are dealing with right here. Is this a bounded or unbounded situation? Remember, less than means that you're within. Less than means you're within the boundaries, okay? Greater than means you're outside the boundaries. So we have a less than here, so that means that you are going to be bounded. Okay, so for a bounded situation, is a conjunction, or we can just use a sandwich situation here. So to get rid of the absolute value bars, we replace it with plus or minus. Plus or minus x is less than 1. Write this as -1 is less than x, and x is less than +1. Okay, you can always do this when you have a less than scenario for an absolute value inequality. Let's go ahead and give ourselves a visual as to what this looks like. So we have our boundary values, -1 and 1, and you're going to be within the boundary values. Are the boundaries included in your solution? The answer is no. Why not? Well, it's because there is no line underneath the inequality, which indicates that the boundary values are excluded from your solution region. And there goes the answer to question number 4. All right, it's your turn to do some practice problems. We have 4 practice problems we would like you to try out. So go ahead and pause this video presentation at this time. Try out these problems. You're to solve the given inequalities and graph. When you're done, go ahead and click on the play button and we'll reveal what the answers are. Alrighty, welcome back. So hopefully you had a chance to try out the problems. Let's go ahead and take a look at what the solutions are. For question number 1, the answer is x is greater than or equal to 3. Let's reverse the order. Let's write it like this. Let's say x is less than or equal to negative 3, or x is greater than or equal to 3. That's a solution for number 1. And then let's take a look at what the graph looks like. Let's do it this way. Both sides. Okay, so we're going to sketch the graph for number 1. Let's just put the lines for all of them so that we can just do it simultaneously. Okay, so for number 1, you can visualize what the graph is. Okay, so number 1 is unbounded, so we're going from negative 3 to 3. So it's going to be closed circle going to the left, and then closed circle going to the right. For number 2 is a sandwich situation. Negative 3 is less than x, x is less than 3. So everything between negative 3 and 3, excluding the boundaries, because we have no line underneath the inequality, so we exclude the boundary values. For number 3 is an unbounded scenario. X is less than negative 3, or x is greater than 3. So what's the difference between 1 and 3? The difference is as follows. For number 3, we have open circles, whereas for number 1, they are closed. Okay, so unbounded to the right, to the left. Number 4 is a sandwich situation or a bounded scenario. So the solution is negative 6 is less than or equal to x and is less than or equal to 6. So we are bounded between negative 6 and 6, and the endpoints are included also. Okay, so there goes the answer to question number 4. So how well did you do in these 4 practice problems? Let us know in the comment section below how well you did, and if there are any questions or clarifications that you have on these practice problems, just specify it for us and we'll be more than glad to support you. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of inequalities, do give us a like or thumbs up. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel for updates to other cool math tutorials such as this. As indicated earlier, if you have any questions, just put it in the comment section below and we'll be more than glad to respond. Tons of support resources can be found at our website at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.